Okay, this is gonna be a little bit of a painful video, but I eventually had to do it. So what we're gonna do is, do you see this big list over here? What I'm gonna do is basically try to read off everything without looking at the book, basically. So hopefully I can do it. If I can't, I can't. But that's the place I'm gonna have to start look into more. So, continuum description of a gas flow. Yes, that's what I remember as let me just follow. As me doing this. So basically the continuum idea is that you have zero initially, eventually you have enough to go up and down until you have a stability like this. That's basically continuum. Is there any more than that? Well, there's a limit idea over here with E over here, I believe, divided by M. Do I remember how to do that? Not really, but I don't think that places that much importance to that. Local thermal equilibrium. This one I should remember more of. Now, thermal equilibrium gives you this equation, H equals CPT, which is DH equals CP dt. It's DE equals CVdt also. Let me think if there's anything else I should remember. There's probably one thing I can't remember. It'll come back to me. Next is our useful additional thermodynamic variables. Well, there's a few thermodynamic variables. H uh, equal E plus P over rho. Now, I cannot remember if that's minus or plus. We'll see later. Because if I remember correctly, this version I do remember. Yes. And then this can be transformed into TdS equal dE plus P, and then it's gonna be, let me check. It's top bottom DD, the low, there's also a low low, obviously there's a low square. Pretty sure there's a negative D row. Okay. So what that tells me is that you have to use this equation to get the rest, which what you have to do is do DH equal DE. And then here is plus dP over rho. And this is going to tell me if it's a minus or plus because I can never remember correctly. dE equals dH minus dP over rho, which equals dH minus dP divided by rho minus uh d1 divided by rho parentheses. And then it's going to be pressure. So this equals that above. So you can see that was right. It is a plus. And then it's TdS equal dE. dE is this, so it's going to be instead dH minus dP over rho minus PD1 over rho plus PD1 over rho, which gets canceled, which we get this final version of that form. All right, what else is there? Hmm, we can go to Stokes equations, but I feel like I'm missing something in additional thermodynamic variables because there's no way this is the end of it. I think this is probably when they introduced ds equal. Well, you can figure it out by doing TdS CVdt plus P dp over rho, right? And then you can say ds equals cv dt over t plus dp over rho t, right? Oh, what does that give me? Um, well, I'm assuming this is a secret, and I think I made a mistake. This is supposed to be a minus. But rho t, what is that? I think ideal gas law is P equal rho RT, and that means that this is R. So we can do this as saying this is equivalent to saying ds equals cv dt t minus R over dp over p, right? Yeah. I take the integral of this as s minus s equals cv ln parentheses t divided by the minus tp. What is this? Minus, yeah, it's minus t reference, so it's ref minus r ln. Also, I'm not allowed to pause, so we're just gonna have to keep on going no matter what. I might get something wrong. We'll just keep on going. Yes. And now with this, we're gonna just divide by CV over here. So ln or R divided by CV. What is that? R equals CP minus CV divided by CV equal alpha minus 1. That's our first equation. And that's informal. I don't remember pressure being like that easily. Mm, I don't like it. Something's definitely wrong because I remember pressure being alpha. No, no, gamma minus 1 divided by gamma. But I don't see a mistake, so it must be right. All right, I'll go. There's no pausing here, so I guess I have to look at my notes, the notes of the that the professor gives, because I will be here for hours just guessing. Maybe double check. I was right about that. I was right about that. Yeah, I did do something wrong. Okay, I did do something wrong. I don't know where that I. Uh, oh, I see. Okay, according to this, I made a mistake here with the CV. Should be a CP instead. So, oh, right. How did I make that mistake? Oh, I don't know. Did I get the state variable wrong also? No, I did get the. Oh, I'm a dummy. DH over here, right? So this is CP. I'm a moron. Yep, that's what I get. Okay, let's erase this now. S minus SO divided by CV. So this equals alpha, which equals, we just follow the ln. And then we can move this alpha to here, inside over here. And get divided by P over P ref by, what is this? RG, right? RG, right? RG divided by CV. Am I correct? Yes. Anyways, with that said, we could do SF0 CV equal to ln parentheses T over T infinity Alpha divided by alpha equals 1. Divided by p divided by p ref equals RG divided by CV alpha, which CV, the alpha equals CP over CV, which means that equals CP, right? Am I correct about this? I don't think so. So with that said, we can do RG divided by CP equals CP minus CV. CP equal 1 minus 1 divided by alpha, right? Which tells you alpha divided by alpha minus 1 divided by alpha equal alpha minus 1 divided by alpha. Beautiful. So this tells you S minus SO divided by CV equal ln parentheses T divided by T infinity, uh, T infinity, right? Uh, divided by R infinity divided by alpha minus 1 divided by alpha and parentheses. Hey, good with that one. Again, we're not pausing, so whatever I say is going to be permanent on this video, no matter what. Okay, so next version is obviously going to be from this equation over here. And I think, ooh, the question is, do we use this or that? I think we use this version, honestly. It makes sense for that version to be used. So we're going to do TdS equal to CV dt plus R, no, plus P over rho square d rho, right? So ds equals CV dt over T plus P over rho square d rho over T. Okay, so I'm going to keep a rho over here because I can see over here P equal rho RT, right? So P over rho T equals R. Yeah, I didn't know I would use that here, but the numbers follow that, so yeah. R d rho divided by rho. And here we have our integral S minus SO equals CV. And again, this is all from my head, except for when I'm desperate, I need to look at the, once again, the book, which is there. I think I made a mistake here. This is supposed to be a minus. This is supposed to be a minus. This is supposed to be a minus because otherwise this division doesn't work. Minus R over d rho over rho. So that's just ln uh, rho over rho over infinity. Okay, so we have everything. And S minus SO divided by CV is here, which equals ln divided by T over T infinity divided by parentheses rho over rho infinity. And let me check what R divided by CV is. This is going to be CP minus CV divided by CV. That is, I think that is omega minus 1. Yeah, omega minus 1, hopefully. I don't know. But that looks right. So we're going to leave it like that. The last version. There's one more version where we have to do something with the ideal gas law. Do I remember how to do this? Not really, but we'll have to figure it out. So I think it is P over rho equal RGT, ln P over rho equal ln of RG over T. Now we see it's ln P minus ln rho equal ln RG plus ln T, which tells you a lot. It's a dP over rho minus d rho over rho equal no RG, this is just a number, right? So we have dt over, what is this? T. A beautiful equation has formed with the ideal gas loss assumption. What does that give me is this equation can be changed here which gives you a relationship over here. It doesn't matter which one we choose. We can choose the each one, but ds equals cv, dp over rho, right? Am I correct about rho? No, it's p. I was about to say that doesn't make sense. Here's p. What's the next one? I don't know. It is minus cv. Is a minus, right? Yeah, I think so. Rho divided by rho. And that is plus by something. I don't remember. I think it is negative d rho over rho squared. Am I correct? Uh, um, am I correct? No. What did I do wrong this time? T, well, I don't know. We'll see. We have, we still have, we still have T over here this time. We haven't moved T yet. Oh, I think it's P. All right. There we go. There's a mistake. There's a P I missed. Okay, this is also fishy. What did I do wrong? Although this is a real question. It's supposed to cancel out. I know it does. I did it before. But what did I do to cancel it out? That's a question. Oh, no, this is wrong. So we have to erase this. No, I made a mistake. So what I substitute is this version over here, which means that we already know that eraser, please. This is going to be negative r d rho over rho. Okay, there we go. There's our secret sauce. ds equals cv dp over p, which is fine. And then there's a minus cv minus r, which is going to be plus, and then it's going to be d rho over rho. And we know r equals cp minus cv, so this is cp. Ah, there we go. And then we integral that s minus so equal ln p over p infinity minus, and this is the times when I love curves because curves show that is fun. It makes class funner, I think, because it I don't know. Sometimes I feel that way. Anyways, I think I did this wrong. I think I have to divide by CV first. Yeah, then divide by CV will give you CV over here, which means this would be alpha instead of nothing here. So just divide by CV first makes everything easier because you can instantly have gotten that this is basically P over P infinity, and then this is rho over rho, and then with the alpha, with omega, or whatever is that, gamma. Okay, good job. We have done all of that basics. Now I can delete this and move on. Let me just grab this. And then we'll just delete it. And what we'll do next is I will check this off. Another question solved. Okay. Next in our list is a Navier-Stokes equation, which has multiple different forms. But first of all, we're going to do rho t plus gradient rho u equals 0. And this one has another form, d rho dt plus gradient, so it's going to be rho v. Am I doing this right? Yes. This dot product here too. Uh, Rho parentheses gradient dot v equals 0. And you see that you see where is it? In this form, this is considered what we call the d rho dt. Am I correct about that? I hope I am. And then it's going to be plus whatever this is, which is rho parentheses gradient v equals 0. Material derivative is a way to think about transport, but that's not. Did I do this wrong? I think this is fucked up here. This isn't right, something's wrong. How do we do? How do we do? Well, uh, no, I'm right. Because I was thinking of compressible, incompressible flow, but incompressible flow just says this, which makes sense if this goes away. And yeah, I'm right. Okay. I was about to lose my mind. I was thinking, how could I mess this up? It's nothing I can think of because it was like, oh, well, I don't know anymore. If I mess that up, I don't know what the next part is because I'm just confused now. Anyways, with that said, we can move on. Next part would be getting rho parentheses rho v tt plus v dot gradient v parentheses. Oh my God. Do I remember this? Equal negative gradient p plus gradient dot tau uh, plus body forces. And that's it. But we don't care about body forces in this class. So we will say this is direct v dt, rho, which is equal to negative gradient p plus gradient dot tau, and then double tau is equivalent to saying parentheses gradient v plus gradient v tau plus something here. Bulk viscosity with 2 divided by 3 bulk and in parentheses something like this. Gradient dot v over here with the identity that I believe, but we never used this so far, so it really doesn't matter. But moving on. No, we need to now do it in conservative form, which is just literally adding this into here. Just trust me and add rho t plus gradient dot rho v, that's a dot, and then you have our rho gradient v dot gradient t. Well, when we add it, you divide by rho and then add another rho. But it should work no matter what. So yeah, equal negative gradient p. So what does this do? Well, I feel like I'm forgetting something with the continuity equation because that's not solving anything. Oh, there's a row here. Does that solve anything? Not really. Am I missing? Oh, yes. No, what do I miss? Is it really just string V V, V, and just dot. I think it's that. Therefore, there's V over here. There's V over here. Yes. And then this over here is a dot product. So it's rho U V dt works. There we go. Plus, and you see there's a gradient here, and then there's a derivative for V over here. Yes, and then this dot product. I think what? I think this is, let me check something. That is, I believe, then it is rho VV equal negative gradient P plus gradient dot tau. And we can do integral form here, which is integral d rho v, and this goes out, dt, right? 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 Okay, I'm a little farther away, but it's still integral. Okay, let's see. It is plus integral s rho v dot, no, v dot dot, and then equal to rho p n ds plus rho s tau dot n. We're done. Check mark. We're done. We don't have to go back to that one again. We did everything for that one. Now for the energy one, I will never remember the integral form and I don't want to derive it. But I do want to get the other forms in. Gradient phi equal negative p gradient dot v. Am I correct about this? I hope I am. I won't look like a fool in front of the internet. And if I do, I don't care. I mean, it's the internet. Who doesn't care? No one's watching me fail miserably. Hopefully. Here it is. It's plus gradient parentheses k gradient t. And we have it. What's next here? Oh, this is supposed to be E. No. Well, the easiest way to think of this is dE dt, honestly. And think of the differential over here and do it. You'll see what I mean soon. Oh. There's a DS version and there's other versions. But this one is how you do it. I think I deleted my what is E, so H equal E plus P over rho. It's only been an hour, so we can still do this. And then it's going to be dE equal H minus P over rho. Has it been an hour? I don't know. I'll show you now. So dE equal H minus D P over rho. So with that said, you can change it to a direct, which is dE minus dt equals to HD minus D divided by P over rho, parentheses dt. Okay. Which now we have a plus P gradient dot V equal double tau bar gradient V plus gradient K gradient T. Yeah, over here now we have a problem. Not really. Because I actually don't remember why. Oh. Oh. But I know by some miracle this happens. This form. I proved it before, I just can't remember how. Oh, I'm getting tired because I have to go to sleep soon. And I don't want to think right now. Both probably. I'm not editing this video, but oh, did I give credit to credit due? All credit goes to these people, man. You know? Yeah. And obviously this is ds. This will go here. Did I get this right? Maybe, probably. This is T ds rho dt equal tau bar, double bar double dot gradient v plus v k gradient t. Now, do I remember the polar form? I kind of remember, but I want to forget it now because it's not useful to me. So I'm going to forget it now. So we kind of did the integral form. Yeah. Those are done. Integral form, yeah, we did better. We did the momentum. I'm not doing the energy, man. That one is taking forever. Euler's equation probably should be next, or t dimensionless propagation we can do. Okay, we did chapter one. We're not pausing. We're just going continuously. That's what we gotta do. We're gonna be psychomantic or something, like they say. But my eyes are sleepy actually now. Probably because it's so late at night, but who's counting? Now the next question is basically just doing a ball. Whatever. And infinity, infinity, infinity. Wow, using Navier-Stokes, which is going to be the momentum equation, because no one cares about anything else usually. Because a lot of people don't understand that momentum, momentum tells us what? I don't know actually. I don't really know why energy is not really here too much about on here. Oh yeah, because density is constant. Yeah. Anyways, I'm actually not going to finish because I'm falling asleep already. I didn't get a good night's sleep yesterday. This is S, right? This is A. This is R. Oh, what I'm supposed to do this diameter. Let's just write the Navier-Stokes equation, which should be written as a ds equal dt equals to the negative gradient p, and it's going to be, what is it? I don't remember. What is this stupid equation? Come on, brain. Ah! Okay, there it is. T over rho, yes. And I did a P over here. With plus a gradient dot tau. You can now do order checks. All right. And now I'm very sleepy right now, so I'm gonna probably stop soon. But we're gonna continue tomorrow. No, we're gonna continue as soon as I fall asleep and get like 5 hours of sleep, and then we're just gonna do it in the morning a little bit. Anyways, I'm gonna stop recording. We'll finish it up there.